Is it? Right. How about there? There we go. I think now it's working. Why is everything so complicated? Anyway, as I was saying, welcome back to the channel. So today's live stream will be covering, of course, TCT Show 2018 Day 2. So basically everyone that I talked to today, which was quite a lot of people. So if I do forget some of the things that I was talking about earlier in the day, then I do apologise. That will be mainly E3D. I mean, I spent probably an hour talking to Greg from E3D and learnt a lot about their toolchanger platform. So there's a lot we can talk about on that. I also spent today an hour and a half, maybe nearly towards 2 hours, talking to Prusa Research about sort of everything. So there's of course the things that you know about already, like prusament and SL1. And there might be some other couple of things that you might be interested to know about as well, so we'll get onto those. But before we get into too much detail, that feels like where I would run an advert. I'm not going to run an advert though. So a message from our sponsor. No, don't worry, there's no sponsor. So where are we? Right, let's go into slideshow mode. Oh, that's the one from yesterday. What a lovely little picture that was. So, oh, before we do that, I'm going to cover a list of who we're expecting to hear from. So today, of course, I've already mentioned E3D and Prusa Research. There'll be a little bit from Rigid Ink, but not a whole lot, nothing massively new. I talked to Bondtech, but I don't think there's anything massively new that you guys won't already know about. We'll cover it quickly. A company called E3D, which is quite interesting. Sorry, just flicking through my notebook for other things. I think that's it for today. But I mean, as I said, I did spend a lot of time with E3D and Prusa, so... Oh no, excuse me, sorry. There's also Photocentric, who you might have heard a little bit about things from already. Maybe not, maybe have, don't know. They have been a fairly popular, well, a very popular stand at TCT this year, so quite a lot of information there. So, who are we going to start with? Let's get something fairly quick out of the way to begin with while people are still joining, probably. So, right, let's switch over to the slideshow mode and change the slideshow settings. So, if I load in images for day 2, please work. Unfortunately, I didn't really get a chance today to go back to the people that I was talking to yesterday and ask them any further questions, because I was kind of exhausted and kind of busy talking to new people. So yeah, sorry about that. So nothing necessarily to add to yesterday's discussion about yesterday's people. So let's do this guy's first. So you have to give this one a couple of minutes while you understand the kind of premise, because it does look fairly basic, but stick with me on this one. So this company is called E3D, and it's basically a printer to be an education platform. So that's for teachers as well as teachers teaching pupils kind of scenario. Not necessarily schools. It could be, I think they were targeting anywhere between sort of 8 years old and 20-ish. I mean, it might feel a little bit patronizing for someone 20 plus years old to have something like this. I think they could probably cope with something that looks a little bit more grown up, because this is kind of laid out in quite a fairly child-friendly format, if you like. So kind of 10 to 12, 15 kind of age is probably more appropriate target, but is kind of fairly well built. They have some pretty good prints off of it. They will be providing the print profiles, which in my mind for a low-cost machine well, for a less stylized machine and maybe less popular machine, I think having those kind of profiles is important to get the print quality that you expect, rather than just whatever profiles you manage to make up yourself. I can't remember exactly what pictures I took. So this is one at the front of the machine. It's got a door on it, it's got a heated bed. The heated bed is optional, but it is in there. And that's by the firmware, it's limited to 80 degrees C, but it could go hotter if you were so inclined. It has a direct drive, extruder, which is very closely based on the Lulzbot. I believe they said they were compatible between one and the other, so if you wanted to switch one over to this or this over to that, then you could do that. Hello 3D Gusner, good to see you. We'll probably talk a little bit about Master Spool in a bit. So yeah, they had, I mean, they were based over in Bristol, so fairly close to me-ish. I mean, it's in the UK, so it's close in that regard. It's fairly, I mean, there's a lot of 3D printed parts, but I think it's really a good platform for education. It looks already well done. As I said, the print quality was very good. What other notes did I make? Oh no, they're not based in Bristol. Why did I think they were based in Bristol? I've written down US, so they're a US company at the moment, and they also have office in Cyprus. So that at the moment they're trying to work through Cyprus and improve their education out there. Education, of course, for schools. So a lot of this outer frame is made by having these, you can see the green clips with a pink zip tie. So that's kind of repeated in a number of places, which makes your assembly process kind of easy to dismantle and rebuild. So if you wanted to rebuild the same printer again, you can cut the zip ties, and all you need is more zip ties rather than replacing the whole kit. I mean, you could argue that you can do that with screws as well, but if you're screwing into plastic parts, there's a fairly limited number of times you can do that before you wear out the plastic parts. Yes, you can have nuts and all sorts of things like that, but then you get into tiny little bits, and it's not necessarily a better way to do it. It's a different way to do it. Not everyone's favourite zip ties, but I mean, they did demonstrate some fairly good print quality and also fairly good printing speed. So it's not anything like I'm guessing Miles the Mad is Miles. Hello. Yeah, it's going to be a long way from Steve 2.0. Steve 2.0 won't look anything like this. What else do we have here? You probably can't see it necessarily very well in the pictures, but I think if we go back to the first one, actually around the back, that might actually be the best way to see it. You can probably see there in front of what is unfortunately an Arduino and ramps combination, there is this labeling kind of laser engraved. Is that necessarily the right term? I don't know. But there's markings, engravings, whatever you want to call them, on the box that shows you a kind of overlay of the components. So if someone wants you to point out where is the X stepper motor, they've got all this engraving on that panel where you can go immediately to X stepper driver, not stepper motor. But yeah, it has all these switches and all that kind of stuff, all the diagrams all laid out. So it's really quite nice to kind of demonstrate where everything goes and what everything is, because it's all right being able to plug A into B and then, oh look, it works. But it's kind of a whole nother deal to actually understand what's going on, know the parts involved, and fundamentally understand the printer, not just be able to put it together. What else we going? I mean, to me, the acrylic is flammable, which is not the best printer, not the best material. They are working, well, they do actually have a touchscreen implementation instead of that archaic screen that you can see in the pictures at the moment, which would be better. It does look very much like a 2012 printer rather than a 2018 printer, but ultimately they wanted it to be clear because that way you can see all the parts. It's not like once it's done, it's covered and you can't see it anymore. But there we go, that's pretty much it. It is, I mean, its appearance is not great. I totally agree with that. It would be nice if it had a more quality feel about it, but it's not about having a great polished machine. It's just an education platform. I think it does need some modification as well. I'm not going to say this is perfect as it is, because I don't even like that control board implementation, but that's what it is. So that's E3D. I'll probably be trying to give them some fairly strong feedback on this to help them get in the right direction, but not too bad, not too bad at all. I'm inclined to agree that building a Prusa might actually be a better idea. I don't know what kind of pricing these guys are looking at the moment, but a lot of education places don't necessarily have the money to build a Prusa. I mean, yeah, Prusa is a great machine, but it's not necessarily great value for money in that regard. You just got the notification that the stream started. That's nearly 15 minutes ago. Okay, so that's E3D. We've got that one out of the way. What's next on the list? We can cover Duet pretty quickly. It's almost not worth covering Duet because I didn't speak to anyone technical. Let's have a quick look at Photocentric. So Photocentric has a fairly busy booth. They had a few printers to show, and let's take a closer look. So I don't know why I've got that picture. This is more of a picture of the booth rather than this printer that's mid-screen. They didn't actually talk to me about this printer, so I don't know exactly what it is, but pretty much everything they do is based around using, as far as I can tell, off-the-shelf display panels from things like tablets, TVs, computer monitors, and all that sort of stuff, laying them flat, feeding them a signal, and printing. So this is all like SLS style, not SLS, DLP, I believe. So it's monitor in the bottom, just like, I mean, it's very similar to the SL1, if you know a bit about that already. So there you go, that's kind of what it looks like. The same kind of upside down printing out of a bath kind of arrangement. Now, the two models that are kind of reasonably priced, so the only two that are kind of feasible in a semi-consumer environment are this machine you're looking at and another one that's basically identical. They're both around $1,700 or pounds. One of those, probably pounds, seeing as we were in the UK at the time we were talking about it. So they have a fairly decent build volume, but, well, one of them has a good build volume and slightly worse resolution. The other one has a really tiny build volume, but absolutely ludicrous resolution. So this is the kind of larger display version of the two reasonably priced options. I think this build volume is slightly bigger than the Prusa. 196 by 147 by 250. I'm pretty sure that's slightly larger than the SL1. The SL1 is 120 by 68 by 150. So yeah, it's quite a bit bigger. Indeed, it is quite a lot larger. But I think the resolution of the panel was fairly similar, because they're not, I mean, these guys are not designing LCD panels to put in these printers. They're taking stuff that's already off the shelf. So if you know a bit about what kind of resolutions are available on things like tablets and phones and laptops and all that kind of stuff, then you get an impression of the size of panels and the resolution of panels that they're going to actually be using. So 97 microns over that size sounds to me like a 2560 by 1440 panel, but on that size. So that's that. In fact, if you do the math, why did I say that? Maths has an S on it. 147 by 250 sounds like 1440 by 2560. And then 196 height. I'm not sure. Either way, that's what it sounds like to me. And this actual model is in fact based off a tablet screen. So it's literally just a tablet placed on a table with a thing fed to it. And it looks to me, I didn't actually ask this because the person that I talked to unfortunately was not particularly technical, but that front panel I'm pretty sure is from a Raspberry Pi. It looks like this standard Raspberry Pi 7-inch touchscreen. So I'm guessing that's what they're using to drive it, because then they can presumably use the HDMI output from the Raspberry Pi to do that. I know Raspberry Pi is not really the kind of control board, but I don't know what they're doing. As I said, they weren't particularly technical. So there you can see the tablet screen sitting in the printer, and then this tray to the side of it. That was super cheap looking. It's basically a piece of acrylic folded round into a box with a clear film on the bottom. It looked very temporary and easily replaceable and easily breakable. But I mean, in terms of print features, it was kind of missing a few things compared to the SL1. So if you consider this, although it has a slightly larger build volume, it's lacking features and maybe will also lack in reliability and things like that. For example, just one easy one, I don't think I've got a picture of it. You can hear, so on this image on the left hand side, just by where the chat is, you can see one of the grub screws and the kind of handle. So there are 3 grub screws in a triangular pattern, and that's what does your leveling. So this thing, you have to manually level it, and for such tiny layer heights, that's not a particularly great idea. So that makes the Prusa version look much better, where they've called it auto leveling. I'm not sure if I totally agree with it being called auto leveling, but it's basically a ball head, so the head is like completely loose until you rest it down on the panel. That obviously sets it at the exact plane of the panel, and then you just lock it in place, and that's it. It then can just go up and down. Whereas this is like all manually grub screwed in, and sounds like a royal pain to me. So if I had to choose between this and the Prusa, I would probably choose the Prusa. Although the big red boxes did look quite cool. These guys did seem to be targeting the industry side more than Prusa do, so it may be that they get more customers in that area. But I mean, their basic technology of having a screen, having some resin, bolting the lot together, and making a printer is basically exactly what they do. So all the printers around their stand were all this exact same, all the exact same technology, just with different panel sizes. So their kind of prototype at the moment is a massive 40-inch screen, presumably a 4K resolution. Maybe they found an 8K panel to go in it or something, but I'm not sure exactly why you'd want to do that, honestly. Seems a bit ludicrous, but that's what they've done, so that's what it is. Don't think there's any like resin level sensor. They're lifting it vertically straight off the panel, which, if you believe what Prusa are saying, that's really not a great idea, and leads to some not great reliability. And yeah, so that was photocentric. Do you get a resin printer? I don't have a resin printer at the moment, and I've never used one. So, yeah. Take anything I say about them with a pinch of salt, because it's mostly opinion or what other people have said. I would like to get one, and maybe I will be able to have the opportunity to use or try an SL1 or something like that. But at the moment, you'll probably see some of the photos I took of the prints from the SL1, and they are very impressive. So, I mean, for me alone, that kind of sells it for very precise parts. But there's just not many things that because I don't have the skill for designing parts that are super detailed, and I'm more of a kind of CAD engineer that makes boxes and holes. Again, as you say, it's not that useful for me, but if I can find an application for it, then I do want to try it, because it does look pretty cool. Right, so let's move on from photocentric. They were not particularly helpful, so I ain't giving them much time. I did mention to her, the lady that talked to me about it, that I had a YouTube channel, and that's why I was there. And she was like, "Oh, I haven't heard of you." I was like, "I'm not surprised." Doesn't sound like you know what YouTube is. But anyway, I had a few people like that, actually. Maybe that was my fault for not explaining it very well. So next, let's have a look at Z-Morph. You might have heard about these guys already. So I think Tom actually covered this thing when he went to a show at some point. So this is by a company called Z-Morph, and it's called the Voxelizer. It's basically a 3D printer, CNC, and lasering machine all in one, with kind of interchangeable heads that you buy separately, all contained within this sort of curvy box. I didn't actually talk to them about it. They didn't seem particularly interested in talking about it, which was odd. The marketing team was not very marketing. But, I mean, it looked really interesting. It looked very strong, very rigid. All the belts are kind of the high-strength belts rather than the standard GT2 types. So they've clearly considered the applications that they're going to be using it for, which is always nice. They got, as you can see on the x-axis, it's kind of a dual belt system. So they have the stepper motors where the I'm losing words because I'm tired. The drive shaft out of the stepper motor. The drive shaft out of the stepper motor comes out the back and the front, and so there's a tooth gear on both of those, and so two belts come off. They did indeed have encoded steppers. They had even a label on the stepper to tell you that it was as such. So this is kind of what it looks like from the outside. It's a bit of an odd design in my mind. I'm not sure why it looks quite like that. Maybe there's some strength advantages somewhere that I've not really thought about, but I mean, it is all well enclosed for doing the kind of CNC operations, so that's quite nice. The machine looks very well engineered. It's been well designed, well considered. So this is the CNC head that's cutting some parts for some drone thing they had on display. So it looks like, well, I think they were trying to give the illusion perhaps that it was cutting aluminium. It was actually cutting Dibond, which is an aluminium composite, which has very thin sheets of aluminium top and bottom, and then a plastic through the middle. So it's very easy to machine. It's good material for machining. It's also very stiff, and it's fairly low cost. So it's good material for kind of doing this with. I'm interested actually in trying to get one. As a CNC machine that is all enclosed, that's quite a nice thing to have. Whether the bed is kind of limiting in size, that could be an issue, but still quite a capable machine. I literally made no notes on this stand other than the pictures I've got, so as I said, I didn't actually talk to the guys on the stand. So they're closed loop system, so there's some feedback loop from the stepper motor to the control board so that it knows exactly where it is rather than just having a set position and then just moving from that reference the whole time. I would agree fully that it's over-engineered for a 3D printer, because it's not just a 3D printer, of course. When you've got to be able to do CNC operations on it, you have to apply the fact that you've obviously got forces then from the head into the machine, rather than with 3D printing there's no force from the nozzle, the nozzle just squidging filament out the end. Whereas when you've got a cutting head on it and you're forcing that into the material, you've obviously got forces then back into the frame and everything. So to maintain your dimensional accuracy, you have to have a lot of stiffness. So yeah, it will be way over engineered for a 3D printer, but with good reason. They do look quite professional machines, I think. Try to get some shots of it inside, but that curvy plastic really wasn't helping anything. This is like one of few printers around that is not using E3Ds. So they've obviously got their own arrangement of hot end and nozzle. So it's probably all closed source, I would imagine. It was definitely on the expensive end. I mean, it's more expensive than a Prusa. I think it's like £1,700. So yeah, it's a premium machine, and the heads and stuff to get you the different CNC and 3D printing capabilities are also fairly expensive. But if it's the kind of thing that you're interested in getting, then I mean, if you maybe run a makerspace and you want these capabilities, but you're limited for space in your makerspace, your maker small space maybe, then could be alright. Haven't they a vortex slicer? I have no idea. Maybe voxelizer is the name of the slicer rather than the name of the machine. I probably should have questioned them a little bit further. As I said, they didn't seem particularly interested. So yeah, that's that. It's quite an interesting looking machine. Shame I don't have any more information about that. I need a drink from talking so much. It's quite funny how YouTube gives me a warning that the video output is low just on the basis that the frames aren't changing. Because all the frames, I have dropped some frames, but just on the basis that the slideshow image doesn't change, they think, oh, there's low video output. Anyway, I think it's probably time to move on to E3D. For reference, most stands that I went to and had a conversation, I wrote like 1 page of information. For E3D, I've got 3, so that's what happens when you have an hour conversation, and then try and remember the whole lot in the next 10 minutes as you write it down. Because I can't really like write stuff down while I'm trying to talk to someone. It's partly rude and partly kind of just stalls the conversation. Before we go anywhere, did anyone have any idea that E3D had a new V6 hot end? No? Well, here's a surprise. They have a new V6 hot end. It feels like they kind of... I haven't even checked their website, actually. I might just do that. Let's all go to E3D website and have a look what's on there. Because they had this on the stand as if it had been around for ages, and they weren't really mentioning it in any way. But I'm pretty sure it's not on their website. Literally nobody knows about it, nobody noticed it as being anything special or different. My internet is going to struggle if I'm trying to do 2 things at once. No, I give up. If one of you could check while I'm trying to stream, that would be fantastic. So this is the new V6 hot end on the left in blue. A nice blue with a screw top. Had anybody heard of that? Because I had no idea. I asked Greg and he was like, is it not on the website yet? I was like, no, I've not seen it. So yeah, they now have a V6 hot end with a screw top. I kind of remember a little while ago them mentioning that they wanted to have this because they don't like the original slot arrangement, but I think that was kind of a rep-rap carryover. Everyone was already using that, so they built a better one that mounted it the same way so that everyone could upgrade. But now they're saying, of course, screws is better than slots. How come you knew about it then? Nobody else did. I had no idea. So yeah, I was quite happy to see that. That looks pretty nice. Yeah, I mean, one thing they mentioned that I'm not sure how amazing it is that you can obviously now orientate it quite easily in different ways. They are the beta designs in blue. So everybody knew about this apart from me then. Okay, well, I had no idea, so I was quite excited. Of course, because it's screw top, it's very easy to just spin it round. You can just rotate it how you like, whereas the slots, I mean, although they're still circular, everything's concentric, it was not necessarily that easy to orient it in the direction you want and keep it there, whereas now you can loosen the nut off, turn it to the direction you want it, and tighten it down. And they've not had any issue with them coming loose, because I specifically asked that, because that seems like a potential downside, but that doesn't seem to have been an issue. So yeah, other than that, I mean, everyone knows about the gold one and the volcano and all that sort of stuff. I mean, they are working on this super volcano, which is absolutely ludicrous. I believe this might have been an overheard conversation about from somewhere else. But it was definitely E3D that were doing some testing on dual 80-watt heater cartridges in a hot end. So that's kind of super volcano hot end. It's made for thin delta heads, made from PCB. Ah. Yeah, I guess that makes sense. I mean, it has plenty of other applications though, right? Because, I mean, they were showing it off on the toolchanger, which is what we'll get to about now. Oh, well, that's the gold one. The gold one looks nice. And that's more pictures of the gold one. I took a picture of all their nozzles as well. I didn't realise quite how many nozzles they had. So you can see those, the plated copper nozzles. They're the kind of new fancy ones. Some stainless steel ones in there. They've got the full range of hardened steel and brass nozzles. And then all the different volcano variants and Cyclops variants. I wasn't aware that Cyclops nozzles were different. I'm not exactly sure how they're different because they didn't look any different to the normal ones. But there you have it. Yeah, so non-sticking nozzles are those plated copper ones, I believe. New coating for heat breaks, I did not see. No. What I did see, if we skip past a few more of these images, sorry, they're not very well edited down. So this is of course the tool changer. I don't know if I've taken the photo that I'm looking for. I'm gonna just kind of squeeze through a few and we'll move back. So I'll give 2 brownie points to the first person that can notice something strange about the way this print is assembled. Because I don't think many people at the show even cottoned onto it at all. It's a little bit of an interesting way to assemble the printer, and they did receive some comments from their finance department about doing it. There's quite a big delay by the looks of it, but I mean, I've put it on super short, whatever it is, I think, ultra low latency, but the latency is still like a minute. If anyone can guess, I will be highly impressed. I'm just going to leave you guys to guess while the nozzles for screws. Exactly. I noticed that almost like one of the first things I looked at on the printer. I was like, hang on a minute. So these are the new special coated nozzles. Well, the retail price is about £20 per nozzle. So they've got like £300 worth of nozzles holding this, holding these panels on. I thought that was just hilarious, and they kind of thought the same. The finance department was like, "What are you doing? We need to sell these, not make printers out of them." But yeah. Anyway, let's go through back some of the images. How many? So, I mean, it might be easy for me to skip through the images separately to me reading out the notes that I made. This is where I might start missing things, because there's a lot to go through. So, first thing, the Z lead screw is a little bit special. Sorry if flicking through all these pictures is somewhat irritating. I kind of want to look for specific image. I probably should have considered this before I set stuff up, but you know you're going to get all the spoilers before I even tell you about it. Oh dear. I don't think they were rejects, actually. From the impression I got, they were actual sellable nozzles. That was James from X Robots in the background. I haven't had a chance to talk to him yet. But yes, he was there with a big yellow dog-looking thing. It was very what's that company in America? That Dynamics thing that had that weird walking dog thing. It kind of looked exactly like one of those. Anyway, Z lead screw. So the stepper motor that they have on this machine, compared to the first one they made, has a special bushing in it. So because of the way stepper motors are typically made, especially ones with the integrated lead screws, if you apply a thrust force, so that's a force along the axis of the threaded screw, then you actually get some deflection down into the stepper motor because of the thrust bearing that it kind of mounts to. You know how a thrust bearing works, right? Yes, Boston Dynamic. Oh, so it has an actual name called the Open Dog. I'm going to try and talk to James hopefully tomorrow and learn a bit more about it for myself. So maybe, I mean, I can't really do a stream tomorrow, unfortunately, because I'm going to be driving home, which takes like 4 hours. So probably this will be the last one. But I might share it at another time, maybe over the weekend. We'll see. So yeah, instead of having the thrust bearing, they've got this bush in there to prevent any vertical motion as you print more and more and more onto the bed, because otherwise that additional load can push that down, which you obviously don't want because it kind of expands your layers effectively. The electronics, you probably already know this, but is based on the Duet and the Duet 5 expansion board. So that's how they get all this operation with all these heads and everything. You can probably, I think, go up to 6 full heads if you want to. There's space for more stepper motors, etc. if you wanted to put things in, but they just demonstrate 4. When they plan to ship this, they're going to be having the electrical stuff kind of all pre-made. So typically with 3D printers, you have the stepper motor wires coming out the stepper motor, and you have to route them all around this weird, annoying way. And then this goes in here, and then you have to get a separate wire and put that there and there, and then another wire and get that there and there. But if you know about how, for example, automotive harnesses work, an electrical harness will basically have all your plugs and cables and everything all kind of bound into this specifically sort of semi-shaped and finished object, which you plug in. You just basically go around plugging it in, pushing it into clips to do the routing, It's all kind of pre-made and all the lengths are right and all the shapes are right and that kind of stuff. So I'm not necessarily saying it's going to be quite to that automotive standard, but that kind of thing where all the electrics kind of pre-lengthened, pre-made, pre-routed, all that kind of stuff to get it right, basically. Now, if we can take a closer look at the X carriage, where the business happens. I mean, that is some images there, but I kind of want to see the ones on the printer if we can. Yeah, that's pretty good. So here you can see we've got the kind of front and rear plates. Oh, no, I'm talking about the right bit. So on the left-hand side of this image, you see the receiver plate for the head with the kind of twisty bit that sticks out. I've forgotten what it's called. But they've changed this manufacturing method from a water jet cut to CNC, because that way they can get a greater rigidity for slightly less weight, or the same weight effectively. Basically a more efficient rigidity in the part, which helps with the kinematic coupling and all that kind of stuff. So good on them for that. They've also done basically the same process for the other side. They've actually switched the sides around. So if we go back and, flick around all these images, you can see on the table there, the left-hand side is the bit we just looked at, mounted, and that's part of the X carriage. And on the back of the part that you can see on the right side is the opposite face to that, which has 3 steel kind of half ball bearings sticking out. They did used to have the bearings on the carriage and then the little rods on the tool, but they've switched that around. Not exactly sure why, but they have. Are the balls pressed in? I don't know. I didn't look that closely. I don't know if they're even full balls, as it were. Don't know if I took one of the back. You can kind of see them on the tools there. I don't know if they're kind of half and then screwed in from the other side, or if they're pressed. I doubt they would be pressed in. It's possible, but it seems unlikely. The rods were definitely pressed in. I'm pretty certain the rods were pressed in, but then obviously that's not a through hole and that kind of stuff, so it's not going to be going anywhere. Yeah, the rods were definitely pressed in, but I don't think there was any chance they were coming out. Steel balls, not sure. We've already pointed out that the nozzles hold it together, which is brilliant. If you saw the first version, have we got a slightly? So this is a fairly good picture. Sorry, it's a bit blurry. So the top side of the image we're focusing on here, where the cables and stuff are all coming out of the tool, up over in a bend back down onto wherever the carriage is located. And previously they had this like strange kind of grabbery arm at the top with the strings and everything on it to hold them all up. And they actually now use what is essentially a steel zip tie and kind of grub screw it at each end. And it basically is like this spring steel thing that goes over the top and just holds the cables. It kind of works perfectly. It looks deliberate and functional, and it's a fairly low cost option. So that works really nicely. They do look very tall and a little bit silly still, but it does the job. While we're on that topic, before I forget it, because I'm not sure I've written it down, previously the tool was all kind of wired in, so the swapping and changing a single tool was not particularly efficient, whereas now they have this little board that Duet have made for them. So all the kind of components in a single tool, like the fan and the hot end example, if you had a 3D printed kind of extruder end, then all of those go up to this little panel in the top of the tool, and then stuff plugs into the top of that. So if you wanted to take out the tool and put in a different tool, then it allows you to swap those out fairly easily. Spring steel, like in the round meters you can buy. See, I asked if they were spring steel, and he specifically said that they were steel zip ties. Whether steel zip ties are made of spring steel, I do not know. They probably are, because they would probably corrode quite badly otherwise, and may have fatigue problems if they're anything too soft. So I would imagine they could well be spring steel, but I was told steel zip ties. They didn't have any ridges on them, which was weird, but anyway. So here you can kind of see that little control board at the top. There's not obviously a lot to it, it's just some kind of adapter board where you're taking inputs from one side and outputting to the other side. E3D didn't have either the direct drive or the Raspberry Pi webcam, but Duet did, so when we get to Duet we'll take a look at those. They've made some changes here to the way the bed works. So on the right hand side of the screen you can see the kind of extrusion strut that holds all the bed functions, and that's a lot thinner and rotated to get the rigidity in the right plane while having less material. They have now the single kind of super wide high wind rail, followed by the lead screw, followed by this kind of massive CNC block, and then the folded aluminium bed construction. Looks very sturdy, it felt very sturdy. It's still a cantilever design, but it's pretty good cantilever design, to the point where they are going to be fairly happy with doing some machining, so subtractive machining processes on the plastic using this bed and tool changer. So it's looking fairly impressive. I mean, the whole bed structure is super bulky, so they are using a glass bed, so that seemed a little bit archaic to me, but if they're getting it super flat and for what they're printing that's fine, then whatever. I mean, ultimately you can put whatever print surface on you want, it's not really important, it's kind of a development platform. Did they say if they get high wind rails or SFK, as last time they said that the high was 6 months on back order? As far as I know, from what I asked, I'm pretty sure they said all the high winds were genuine high winds. They were all black, which looked pretty cool. Maybe high wind don't do black, so that would be maybe one way to identify. I don't think I asked actually about the rails. I asked specifically about the belts, but not the rails. I thought the rails might be made out of some weird carbon material because they were black, but no, it was just, I think, a coating on the metal, on the steel, not just generic metal. So the heated bed, this is also a little bit special. So this is a mains powered bed, of course, that's the right way to do it. It uses an SSR to control it, of course, still the right way to do it. The actual heat generating portion of the bed is actually physically fused to the metal. Why do I keep using that word? It's because I'm tired and my voice is going. So now I've forgotten what I was saying. Yeah, so that silicon heater is basically fused to the aluminium bed. And basically that means that instead of the stick-on ones that could potentially come off after a lot of use, a lot of heat cycles, it will actually just stay stuck pretty much forever. Personally, I've not had a problem with them coming off. If they've been stuck on with 3M adhesive, I mean, trying to get rid of 3M adhesive, even when you want to, is difficult, let alone it accidentally coming off over time. Normally, if it's stuck down with 3M, it's stuck down pretty solid 3M, everything 3M just sticks like, well, it's sticky. So yeah, 800 watt mains bed does seem a lot of wattage for what is not a massive bed, so that's probably going to heat up very quickly. Presumably that doesn't generate too much in the way of warping because it's all well spread over the aluminium. Unfortunately, the machine actually wasn't running. I mean, it was moving, but Greg had only built this printer on Monday, so he hadn't had enough time to basically set up a custom G-code to run anything particularly special, which is unfortunate, but that's the way it is. I did ask them a bit also about the assembly time, because obviously it's a fairly large machine. Assembly time is fairly important. You don't, you don't necessarily want to be spending hours upon hours and hours trying to assemble something. So, if you know already, this will be a kind of pre-assembled machine, partly. Anything about offset of the different tools, how it's made? So, I think we'll get onto that in a minute. I think I mentioned it. Yeah, I've got that, so we'll get into that. So the factory assembly at the moment, they did a test where someone followed instructions that were pre-made, and they'd not looked at assembling the printer before, and it took them 90 minutes to build the printer from scratch. So an hour and a half from nothing. That's pretty quick. Now that is with only hand tools and the very first time they made it, and this is for their factory assembly kind of process. So, I mean, even for a full printer, that is pretty quick. Not many parts involved. It's a very well DFM'd printer. But for users, which I mean most of us are going to end up being, the actual assembly time, because a lot of it is pre-assembled to these top and bottom plates. No, sorry, pretty much all to the top plate. There's pretty much just 10 minutes of assembly for an end user. It's pretty good. I've already mentioned the change of orientation on that Z plate, Z brace rather, like the main strut. Something at the base, not the top. Yeah, I'm struggle to remember what my notes were trying to tell me. Oh, it is all genuine high-rin rails, so I obviously did ask that and then forgotten I'd asked it. So yeah, all high-rin rails. Genuine gates belts. All the idlers were gates, the tooth idlers were gates. It was just gates everywhere, gates galore. The little access board we've already talked about. So for bed leveling, you can see actually this is a really good image. So if you see on, well, from this angle, the bottom right of the image, on that corner of the assembly, you can see the little blue dot, blue circle with a little black dot rather in the middle, and that is the Z probe. So I mean, typically you need a BL touch because you've got your print head and then the rest of your body, and you want to be able to retract that touching probe so that it doesn't contact the print when you're actually doing some printing. But because here you can just like dump that extruder somewhere else, you can just dump it off, do the leveling without it, and then bring it on. And then all the calibration, all the distances to kind of set up a different tool, just need a reference geometry from, for example, the center of the clamp would be a center point, a reference point in the kinematic coupling, down to the tip of the nozzle in XYZ, and then it knows exactly where it is. So that's how that is all done, which then allows you, because you're kind of giving that information as a tool rather than just as a general carriage assembly, you can have tools of different lengths. So if you've got like a standard V6 and then you've also got maybe a direct drive volcano, then the height at which those nozzles are going to sit could be very different, and it can cope with that just fine. So yeah, that little limit switch is just a micro switch. I hadn't seen one that looked like that before, but that is what it is. They did used to use a BL Touch, but obviously now that they can just dump the tool to do the bed leveling, then don't need that. For end stops is using stool guard, trinamic drivers, remember, so easy, basically free way to do that. Talked already about bed stiffness. They do use a slightly stronger spring, I believe, than initially on the servo motor that controls this little grappler. I don't know what it's. Basically, the arm that pulls in that kinematic coupling is really strong. I did feel it and tried to kind of pull it off. I'm not really concerned with that coming off at all. I mean, the only chance that you might is if you're running at like maximum acceleration with a heavy NEMA 17, like sticking out miles, but it seems fairly unlikely to come off. It is a very strong spring. Can't read my writing on a couple of notes, so I'm going to have to skip those. Last note I've put in that the rails, so the linear rails, they have it's a 9mm one on the x-axis and a 12mm ones on the y-axis. Not that that particularly makes a difference, but that's what it is. I see what you mean, yeah, so how do they refine the last few microns of a tool? I suppose you just have to measure it really precisely. I mean, their assembly, there's no real reason for your nozzle to be off once it's set for that tool. There's no reason for that tool to become any different dimension. So you just have to measure it well, I think. I mean, they're planning on supplying these tools, so they would presumably give you the data about each tool that's assembled so that you know the exact offset that's needed for the firmware, etc. Or they'll assemble them in a jig that gets you precise repeatability. I suppose then you have different issues. As soon as you change the nozzle, you've got to remeasure it and get it super precise. Don't know how they do that. Yeah, not sure. Yeah. I mean, maybe they do. I don't think so, though. I don't remember seeing any other way to measure anything other than that little Z probe. Let me know if you see something in one of the images, but I'm pretty sure there's nothing else particularly special in terms of measuring heights. That X carriage rail, of course, the X rail made out of epic looking carbon, which is got to be super light and rigid. I really want some of that stuff. Nice black hybrid rails, look really good. Just a couple of different angles we've got here of the rest of this machine. That's the whole thing. Pretty beastly machine, it's fairly big. I mean, compared to other machines at TCT, it actually looks really small because you've got some absolutely whopping machines there, but for standard printer size machines, it's definitely on the large side. And that's pretty much it for E3D, I think. And I've got this one last photo. Not really sure why. Okie dokie. Right. It's already 10 o'clock. Right, we're going to have to absolutely steam through the Prusa stuff. I'll try and focus the Prusa discussion as much as I can onto things that you won't have seen already, or won't know about already. Day 2, Prusa. So of course we've got basically 3 things from Prusa. You've got the SL1, of course, that's super interesting, MMU 2.0, and then prusament. So let's have a quick look at MMU 2. Great pictures, by the way. Thank you very much. I have also been surprised at the quality of my own pictures. Encoding overload. Consider turning down video. Well, thanks OBS for the warning, but you know what? It's just a picture. I'm sure it's going to be okay. I don't know why my pictures have turned out well. I don't understand what I've done, but whatever it is, it obviously seems to have worked. Just kind of luck as much as anything, I think. Or maybe I finally started to understand how cameras work. I'm not sure. Either way, thank you very much for your kind words. So, multi-material, of course, you got 5 spools, all feeding into a single head, and that allows you to do all this magical multicolour printing. They also had a little demo of the coloured infill kind of thing going on. All of the colours were super bright. In fact, that pink was amazingly bright. You could see it from a mile away. They were very vibrant colours. I need to get a closer look at that white, actually, because I mean everyone can be very critical of whites. Whites can be like a cool white, a warm white, like a naturally looking white. Is it slightly off-white or is it pure white, and all this kind of stuff. So whites can be quite a good indicator of quality. Honestly, I'm personally not that interested in this, so I didn't really chat at length about the multi-material thing. This is one of the photos I took today. A couple of the others were actually taken yesterday. You can see a couple of the prints there going on the PEI bed. Prusament sold out in 30 minutes after announcement. Blindly. Can't say I'm surprised. They probably only had 10 in stock. One thing worth noting here, you can actually see it in the back of this image, the cover for the cables. Like the cable guide is a different wrap to what the early Mark III shipped with. I think they've made a post about that fairly recently. You've got this, obviously the multi-material 2 with a little bearing and the Pinder kind of hot end. Pinder hot end? What am I talking about? The Pinder sensor that they use for leveling, they've used as a filament sensor in this, which is quite a fancy little arrangement. I think there's quite a lot of documentation about this multi-material already. This is a powder-coated bed. They're still having some issues with the quality of these. Interestingly, it appears as though the quality doesn't necessarily affect performance in terms of printing, but they just generally look horrible because like the colour all doesn't, it's not uniform. You get like really blotchy bits and then bits that can just come off. So yeah, yep, cloth sleeves on the cables, much nicer. So this is actually not the coloured infill, is it? This is just outright changing coloured prints all over again. This was a really weird print because you can see it's like mostly yellow and then suddenly everything's just randomly changing colour. So presumably this is one of those prints that they set up to see, so you can see a lot of colour changing with actually not a whole lot happening. There you go, there's just one thing that concerns me about having 5 spools like this is the amount of space it takes up. Can you see the gate spells? Yep. Nice, good quality belts. Okay, that's it for multi-material. I've got to change again. Oh, I keep pressing the wrong buttons. Image slideshow. Change this to add a directory. Prusament. For some reason I managed to only take 3 pictures relating to prusament, and one of them is this, and then there's probably another one of this as well. So in terms of prusament, I would highly recommend that you go to their website and look at the sample data, because there's a lot of information that comes with these filaments. So if you didn't already know, there is a QR code on the side of every single spool, as well as every single box. You know what a QR code looks like. So you can scan that QR code, open it in a web browser. That takes you to the page that's for your filament, not just your type of filament, but that exact roll and the dimensions taken as it came off the production line. That production line machine takes measurement data at 4,000 hertz or 5,000 hertz, I believe. So 5,000 readings per second, 5,000 measurements per second. There might be 4 at a time if it's doing like x-axis and y-axis or 2 axis, whatever. It takes a lot of data. And all of that information is available to you, which is absolutely ludicrous. You get this like graph, and every spool has like a tolerance. So instead of just saying, as you can see on that sheet, plus or minus 0.02 manufacturing precision, yeah, that's true. But in fact, for example, the spool that they gave me is actually, based on the exact data for my spool, is plus or minus 0.015. So it's even better than that. So it kind of is weird in a way, because presumably at one point they're going to get one that's like plus or minus 0.001 or something, which will be absolutely ludicrous, and maybe it won't happen, but there's going to probably be at one point this like golden spool of nearly perfect filament. Well, I did talk to them about why they want this. I mean, I think ultimately for them it's about having an ecosystem that has everything. So at the moment they can do all the work they like in terms of having smart technologies and the right belts, the right services, all the right stepper motors, the right frames and all this. So they even have their own slicer and all that kind of stuff. So they spent a lot of time trying to make everything as perfect as they can through the hundreds of hours that they have of testing of their printers. And then someone can just go and bung some cheap filament in, and like half of that work's basically redundant. So they're bringing this out to kind of say, this is how filament should be done. If you want the best from our printers, use our filament because it's the best. That's pretty much, as far as I can gather, that's pretty much their reason for having it. It's to get the best, use the best, and we've got it for you. At the moment, materials-wise, I think it's just PLA, so nothing particularly adventurous, but I would imagine there'll be more coming in the future. There were quite a few colours. One particularly nice one was, there you go, you can see all the kind of different colours on that sheet, was this. This is I think they're royal blue, and my god does it look good. It has this like really nice sheen, but also like this kind of dual tone where it kind of looks matte in some directions and then shiny in others. It looks ridiculous. It is a good price, yeah, 25 euros is nice. We don't know what the shipping is going to cost. Hopefully not too much, but they've given me a spool of the Galaxy Black, so if you know there, it is blue, not purple. Yep, definitely blue. Royal blue, they called it. Yeah, they've given me a filament Galaxy Black, so if you know what their frames look like, the kind of black with the little sparkle in, or if you've seen Tom 3D's, Tom Sandlander's Infinity Blue that he made with, I've forgotten the name of them, Das Filament, a company called The Filament, you think would be easy to remember. So it looks, yeah, very similar to that, and that actually hides any line artifacts really well. Scanning the QR code. Yeah, loads of information. I recommend you go and have a look. The website is up now, www.prusament.com. Will this be available in the US via Amazon? I believe it will be. I actually did mention to them, kind of almost in a joking way, that like you can get these replacements. It was actually when we were talking about the SL1s, like these replacement films are only €2, and I was like, yeah, but it's €30 shipping, right? At which point we had a bit of a discussion about shipping costs to the US and using Amazon and that kind of thing. So they're 100% working on that because they understand that you guys don't want to pay outrageous prices to get something that's maybe only worth €2. So they are definitely doing what they can to try and get those prices down. Right. What else was cool about prusament? So in terms of recyclability and all that sort of stuff, there is no master spool yet, and they're not currently planning to do it, but if plenty of people ask for it, then I don't think they're going to avoid it. At the moment, the filament spool has actually a cardboard center, and you can physically pull it apart. So if you were to buy filaments from elsewhere and put them into those spools, you can kind of reuse the spool, but Prusa don't currently sell the kind of refills for master spool. I think part of the reason for that is it's kind of a manual process to do, and Prusa is, if you've seen any of their factories, you can see how heavy on automation they are. So manual process, not great for an automated environment. But they do have this kind of nice mesh design. I don't know if I haven't got any images over here, but you probably saw it in the images I showed just now about the multi-material. So there's quite a bit there. It kind of is basically just a weight reduction from a general spool. I've not actually checked the mass of a general spool, but I think they were saying theirs is 240 grams, so it might not be a lot off, but it is a bit, so every bit helps. Of course, if it was master spool, that would be even better. So yeah, if you're interested in master spool, definitely go and tweet at Joseph Prusa or at Prusa3D, and you'll find out. Labels on the box. The graph is actually also on the box. So I mean, the idea of having all that data on the box seems kind of weird because you could almost go into a shop. Not that they have an actual shop, but for argument's sake, let's say they have a physical shop. You could go in and like browse all the colours, browse all the filaments, and find one that's like a golden spool of like this one's plus or minus 0.002. So I'm going to have that one because it's like 10 times better than the others. You kind of have this like rarity gauge of spool based on the actual tolerance of the sections shown. The website, if you want to go there, also has this nice calculator for showing how much material you have left. So I mean, it's quite easy if you know how to do some basic maths to do the calculation for weighing what you currently have, weighing an empty spool, and the difference is how much filament you have. But this calculator goes kind of one little step further, takes that mass and basically converts it into a length. So it gives you a length of filament rather than just a mass. Is that more helpful? That's up for you to decide. But ultimately, everything they're doing is really cool, and I'm sure we'll find practical uses for it in the months ahead. I need to kind of try and wrap up, so we'll just try that very last thing now. Oh, messed that up. I've just deleted my slideshow. Image slideshow. Okay. Directory. Prusa SL1 open. Okay, I think this is going to come in really massive, probably. There we go. Yes, absolutely enormous. Brilliant. Oh dear, transform. Sorry about this. Oh no, that's not what I wanted to do either. This is not going well. It's also automatically saving things now, which I don't want to do. Oh, come on. Fit to screen. Right. Okay, it's just going to cycle the image probably now. So, SL1, print quality. Let's stop on that image because that is a ridiculously fine detailed print. That tiny little thing is, it's not going to stop. It's just going to keep going. Is really, really tiny. It's really quite a phenomenal. I don't have much in terms of measurements to show you, but all of these things are pretty small. So show manual. Oh, has this gone back to the beginning? I think this might have gone back to the beginning. Now my hotkeys don't work. Oh, okay, let's just put it back to automatic. So you guys are just going to have to bear with that. Sorry. So you've got a HEPA filter on the back of the machine, and that's basically pulling air through the machine and out the back, which has a little filter in it. A HEPA filter, which is a high efficiency particulate air filter. You've got a kind of attachment point for that, so you can attach it to an extraction tube, which will allow you to vent the fumes immediately straight outside rather than just into a room, regardless of whether they've gone through a filter or not. The DLP panel, because this is effectively a DLP printer, because it's using a UV screen to cure the filament. It's a 2560 by 1440 panel. So again, a fairly standard 16 by 9 resolution. So of course you have a 16 by 9 ratio bed. There are very few printed parts on the printer, so compared to something like you might be more, well, compared to the Mark III, for example, there's very few printed parts. There's like a few things for mountings inside, like a fan and control wall and stuff like that, but nothing like majorly functional is 3D printed. They do have, you might see as it loops past, one of the knobs on the top of the printer, well, that kind of holds the, you'll see it, there's like this big turny knob that's printed on the top, but as far as I know for the production models that's not going to be printed. They just had it like that because the ones they bought were actually not very good, so they decided to print their own. The control boards inside is not an INZ, so they're using another custom board that belongs to them, and there's kind of two boards inside, so you've got one for the front panel, the screen, which is a touch screen, which is a saviour. So it looks like Prusa will be moving away from having terrible little old technology for their screens, which is really exciting to see. While we go into this, you might want to know a bit of background about the SL printer. So in fact, although Prusa as a company has designed this printer from scratch, the printer kind of semi already existed. So they actually purchased another company in Prague, or in the Czech Republic. No worries, Rob. Thanks for listening. So yeah, they purchased another company that already had this kind of product, but the company itself was not doing very well. So they purchased this company in order to get all their technology and all their sort of expertise in the field, and that basically helped them to develop this printer by having something as well, some experienced people that have worked on these printers before, as well as some kind of resemblance of a design that they can work upon to build their own. So in terms of connectivity, it has USB, Wi-Fi and Ethernet, so you've got Ethernet at the back, Wi-Fi from the control board, and then USB also at the front. If I just if you want to print directly from that. Of course, as I mentioned, touchscreen on the front. The bed leveling system is really super simple. You've got this like ball head at the top, so what other things use a ball head? Not many things I can think of applicable to 3D printing. But basically, you unscrew the screw at the top, and it means the bed can basically tilt. Of course, the bed is facing down on this kind of printer. It can kind of tilt in any direction. It's basically completely loose. You then lower the whole system, and that brings the bed down basically in contact with the screen. And then at that point, you tighten the screw, and that basically sets that bed level perfect to the screen. There's no like calculation or anything involved. It's just a manual, a physical contact. As when they touch, they're flat together. They must be parallel. Therefore, tighten knob, job's good. Super simple way to do it, and really effective. However, this is still a resin printer. They've not made some magical resin. In fact, they're not supplying resin at all at the moment. So resin is still toxic. It is still fairly, like, not dangerous, but it is toxic. So you're going to have to find some of that stuff yourself, as they're not selling it. And you should be aware of all the kind of dangers involved with handling this kind of stuff. So you'll need kind of a special environment in which to do this kind of work. Now, probably the most interesting bit about this SL1, in terms of like complexity, nerdy stuff, is the resin level sensor. So I didn't get like a hugely detailed explanation of how this works, but it sounds pretty cool. So hopefully I've understood what I was told, and they understood what they were told. So as far as I know, Joseph Prusa's brother, I think his name was Marcus, but I'm also not totally sure on that. I might have remembered that wrong. I'm pretty sure it began with M, so apologies for getting your name potentially wrong. But as far as I know, they have these kind of contacts that kind of the screws that hold on the bottom of the bed. So as you can see in that picture that's kind of showing now, hopefully, as long as that's not in a lag compared to what I'm talking about, they connect into an electrical circuit. Ah, Michael Prusa, yeah, that sounds right. Yeah, thank you. Saved me. Yeah, so those screws connect into an electrical circuit, and they measure the capacitance across those screws, because those screws are kind of in contact sort of with the filament. It's kind of isolated from the rest of the printer. So basically what they can do is they apply a small voltage, I think, to basically that bed resin, and the capacitance measured of that circuit tells you about the quantity of resin in that bath, basically. So it's a linear correlation. As the capacitance increases, there is a linear increase in the amount of resin present. Now, different resins do have different capacitance, so this is not necessarily perfect at the moment, but it does definitely give you a very strong correlation between the amount of resin in the bath and the capacitance measured, which is pretty cool. And obviously from that, you can, if you know about how much is in there, from there, well, from a certain capacitance, you can then work out how much is in there, because you've got sort of length, width, depth, density, all this kind of stuff. And that will then let you know if you've got enough filament to even complete a print, for example. If you're just about to start a print and you're looking, well, I've got this bath of filament here and it's going to make this solid thing. How much of that bath do I need to make this thing? Well, obviously the idea of this sensor that will be able to tell you that before you start the print, so you don't have any problems during the print. Right. I am now utterly exhausted, and I think that's covered everything from day 2. So, does anybody have any questions that I may or may not be able to answer? I can try, but I can't make any promise because I don't know, and I'm super tired, so probably can't think particularly straight either. Of course, thank you everyone for attending. It's nice to speak to you guys as we're doing it. Thank you, 3D Guster, that's very kind of you to say. I'm always happy to spend time talking to you guys and explaining what's going on. I say explaining, I don't think I explained anything necessarily, just translated, conveyed the information that I was provided today. It is a really interesting show, so if anyone can make it, or make it to another one, Prusa invited me, not Joseph Prusa, but the Prusa team, Nicholas invited me to, well, suggested I go to the Prusa Maker Fair, so I might try and attend that next year if I can afford it. So that should be good fun. I mean, obviously it's not the, what did I call it? The Prague Maker Fair. It's basically the Prusa edition Maker Fair. But I mean, it was very popular last year. It was very good, so no reason why I won't go next time. So I think that's going to be it for today. I'm not seeing any questions, so I don't know how much of a delay there is, but yeah. Thanks everyone for watching, and I shall see you in the next one. Oh, one quick question snuck in there. When can we expect your issue 602 update video? I really don't know. I don't have a very good answer for that. In terms of where I am at the moment, all the testing is done, all the analysis is done, all the comparison is done. I've written about 6 pages of kind of in a report structure of this is the method, this is the stuff, this is some tables and all that kind of stuff, and then there's some kind of conclusion and recommendations and stuff. It's all written down, but I've not made it into any sort of video at the moment. So it may be I end up just like taking all this script and having a live stream and mashing it out in a 2-hour live stream as we go through all sorts of things. Or maybe I'll just do it in a video, but I haven't got around to it yet. If I hadn't taken this 4 days to come up here, then I obviously could have spent more time working on that, but TCT was pretty good fun. Right, so we're definitely come to an end there. About an hour and a half, I think that was. Yeah, well, 15 seconds over, well timed. So that's been it for me and this TCT Day 2 roundup. It was very interesting, spent a lot of time today talking with E3D and Prusa, as you now know. Yeah, everybody hit that thumbs up and subscribe if you haven't already. If you sat through an hour and a half of me blabbering and you're not subscribed, then you probably should do. I think you'll probably enjoy the rest of the content I have coming and have already made. So yes, cool. I shall say thank you again. Thank you, thank you, thank you. Thank you, and goodbye. I shall see you in the next one.